Hello everyone. I hope everyone is having an amazing time over there, and I welcome you all to our live discussion plus session on mock test 8, the test which was conducted on 9th of March. Alright, so let's continue, and some of these topics which you can see over here, I had myself held a session on these, if you remember, right? And we had covered various topics, and we are going to do some more interesting problems today. Yeah, good morning. All right, so let's begin. The first one that's coming up is your wave optics from your class 12th. All right. And in this one, coherent waves, we had talked about a little bit, right? Let me give you a small explanation about what these are, right? Wait a minute. Coherent waves. So these are what waves, right? Remember, these are waves which will have a constant phase difference, and as the time goes along, right? Obviously the waves are also moving forward, but remember that the phase difference between them, it will remain the same. Okay. Have a constant phase difference between them. Okay. Constant phase difference between them. Okay. And for phase difference, what was the symbol that we had used? Phase difference, right? The symbol is delta phi. We will do one or two good questions on this as well. But please remember this one. The phase difference has to remain the same. All right, so let's see the first question that's coming up. Two coherent waves are given. They're represented by their equations, right? Y1 and Y2. Y1 is 4 sine omega t, and Y2 is 3 sine omega t plus pi by 3. Right? So the moment you see the equation, you should be able to figure out what is the phase difference, right? So can you tell me what is the phase difference? If you see over here, what is the argument of this sine term? Omega t, and here omega t plus pi by 3. So the phase difference is nothing but you just have to subtract them, right? So this is phi 1 and phi 2, phi 1 minus phi 2, or phi 2 minus phi 1. So what is it? Omega t plus pi by 3 minus omega t. That is pi by 3 only, right? So let me just write down. Phase difference is pi by 3, okay, and these waves interfere at a point, and what are we supposed to find? The amplitude after the interference, right? And remember, if you want, I can write it down over here. Let's say those waves which are interfering, they have intensities I1 and I2, okay. So what happens after the interference, right? So you can remember it like this, resultant, right? I resultant, it will be equal to I1 plus I2, okay, plus 2 under root I1 I2 cos, right, cos delta phi, okay. This is why the delta phi I was talking about, right? This phase difference which is remaining the same. Okay, and I1 and I2, obviously it remains the same, right? And what is their connection with amplitude? Remember that intensity of that wave is directly proportional to square of amplitude. So A square, okay? So I1 is proportional to A square, that is A1 square. I2 is proportional to A2 square, right? This way you can remember the formula. I1, I2, A1 square, A2 square, then whole under the root, that becomes 2A1, A2. Okay, and then you have cos delta phi. Right, and what about over here? LHS, left hand side, I will be proportional to amplitude square, or we can say the resultant amplitude square. All right. Yes, Pankaj, a very good morning to you. So, let's see what that question was, right? If you see over here, the amplitudes are given, isn't it? Please see carefully. This is your amplitude 1 and this 3 is amplitude 2, right? A1, A2, delta phi is also given and resultant amplitude we have to find out. So which formula we will use? The formula for amplitude which we wrote over there, right? So I will directly use, here I had written a square is equal to, right? But I will just write for a is equal to, we will take whole under the root. So a is equal to square root a1 square. A1 square is your 4 square plus a2 square plus 2a1 a2, right? So 2 into 4 into 3 into cos delta phi. Delta phi was pi by 3 and pi by 3 is how much degree? 180 by 3, 60 degree, right? So I'll directly write cos 60 degree over here. And cos 60 is how much? 1 by 2. So 1 by 2 and 2 will get cancelled. 4 into 3 will become 12. So what does this become? 24. 24 plus 9 plus 12. Right? So now if you can calculate, what does this become? Oh no, wait. 4 square, right? 4 square is 16. Yeah. So 16 plus 9, 25 plus 12, 37. Right? So root 37. And this is little more than 36. So root 37. Little more than root 36, which is 6. So little more than 6. So it will be roughly 6.1, right? Yeah. Yeah, Kea Sinha is asking what is called coherent waves. I'm new here. Yeah, Kea, as I had previously introduced, coherent waves, so these waves are coherent. They have already said. And coherent implies the phase difference between them, right? This is the phase angle and this is the phase angle of this wave. So the difference between the phase angles, which is the phase difference, it will remain the same. So here the phase difference is how much? Omega t and omega t plus pi by 3. It is pi by 3. So the phase difference remain the same and we are calling them as coherent waves. Okay, it was a very simple question, right? Here if you want, I could have asked a different question, which is find the resultant intensity, something like that, which is what the next question is. If you see over here, the same two coherent waves, but here I have changed the equations. I tweaked it a little bit. See? The previous one was in sine. So here it is cos and the amplitude here is A1 and here the amplitude is A2, right? A1 and A2, right? Cos and cos. So can you tell me what is the phase difference between them? What do you have to do for phase difference? What did I tell you just now? You just have to subtract the phase angle, right? But here we won't be directly subtracting. Why? Because if you see, omega t has a positive sign and here omega t has a negative sign. So let us change this second equation a little bit. And if you want, I will read the question as well for you, which is if two coherent waves represented by y1 and y2 interfere at a point, then their resultant intensity. We could have also found resultant amplitude also. Okay, so what we will do, we will rewrite this equation. How? You see over here, y2 is equal to, I am writing it as A2, right? A2 cos, what can I write it as? If you remember properties of cosine, which you must have read in your 10th class, right, which is cos of minus theta can be written as cos theta, right? Little bit small application over here. So what I will do, if this is minus theta, I am going to write theta, that is just multiplied by minus 1 over here. So if you multiply by minus 1, if you see pi by 2 into minus 1, minus pi by 2 and minus omega t will become plus omega t. So here what I am writing, cos omega t minus pi by 2. Okay? I just have taken out the minus sign, or you can multiply it by the minus sign. So you will get this. So now you can find the phase difference. Now you can find the delta phi, which I wrote over there. Right? I had written a delta phi over there. So what will be delta phi here? Subtract the phase angle. So omega t minus pi by 2 and omega t, just subtract them. The phase difference will come out to be pi by 2. Right? If you want, we can subtract omega t minus pi by 2. So it will become pi by 2 only. Okay? Pi by 2. And use that same expression which we had done for amplitude. But here we are not asked to find amplitude. Here we have been asked to find resultant intensity. Right? still we can write for amplitude, right? So amplitude square is equal to A1 square, right? A1 square is A1 only, so A1, small A1 square plus A2 square, isn't it? This was the formula, wasn't it? See, this formula we are using. So if you use it, A1 square plus A2 square plus 2A1 A2, 2A1 A2 cos delta phi, that is cos 90 degree, right? This is 90 degree. This becomes 0, right? This becomes 0. So you're left with A1 square plus A2 square, right? So A square is nothing but A1 square plus A2 square. So if they had asked what will be the resultant amplitude, what would your answer have been? The answer would have been under root A1 square plus A2 square, which is capital A. But here they are not asking, they are asking resultant intensity. And resultant intensity, I, just now I told you, it will be proportional to amplitude square. This is the resultant amplitude. So amplitude square, so we can say resultant intensity will be proportional to A1 square plus A2 square. So I hope this one was clear, right? So the correct answer would become option 4, right? Yeah, thank you. Happy Holi to you as well. All right, very well. Very well. Now see this question. It's also a very simple question. No need of any big calculations, right? If you remember the formula. If you see, in superposition of two waves, phase difference corresponding to a path difference of lambda by 6 is the path difference. So simple formula, right? Phase difference, what is the symbol? Delta phi. Path difference is delta x. And what's the relation between the two? Delta phi. Simple formula, delta phi is equal to k delta x. Right? This is what we have to find out. K you already know, right? K is 2 pi by lambda, where lambda is the wavelength, and delta x is also given in terms of lambda. So delta x would be lambda by 6. Simple cancellation of terms leads you to the answer. See, 2 and 6 will become 3. So the answer would be pi by 3. Right? Very simple question this one was. Such kind of simple questions will definitely find their way in your NEET paper. Right? So please keep practicing such direct questions also. Right? Yeah, clear. Okay, very well. So I hope this question was clear to you. Okay, so now moving on to the second topic which we had discussed some time ago, YDSE, right? Young's double slit experiment. And if you see what is given over here, the width of fringe is 4 millimeter on the screen in a Young's double slit experiment for the light of wavelength 450 nanometer, right? So fringe width is given and the initial lambda is given. So let me call this as lambda 1, right? And the width of fringe in the same experiment for the light of wavelength 700 nanometer will be, right? 700 nanometer will be. So now they have changed the wavelength, right? So lambda 2 they have changed, okay? And they are asking the new width they are asking, right? If you remember, fringe width, we had derived the formula for beta, isn't it? How did we get the formula for beta? I had explained, this is your general diagram, right? At a particular point on the screen, you will get, let's say, a maxima at a particular y from this central point, which is your central maxima, right? That y, if a maxima is formed over there, let's say nth maxima, right? So for nth maxima, that y would be equal to how much, right? Right? Let's say for nth maxima, it will be n lambda d by small d, n lambda d by small d. And remember, fringe width you can find by, let's say, distance between two maxima or distance between two minima, consecutive or successive minima or successive maxima, right? So this is nth maxima. Similarly, you can find n plus 1th maxima, and you just subtract the y between them. That would give you the distance between the two maxima. Similarly, you can do for minima also. If you subtract them, you will get distance between the two minima, right? If you want, we can find out. If I write for n plus 1th, what will that be? N plus 1 lambda d by small d, right? And if I subtract them, what that comes out to be, right? If I subtract, that is yn plus 1 minus yn, right? N lambda d by small d, they will get cancelled, and you are left with lambda d by small d, right? And this is your formula for fringe width. All right, someone is asking, sir, please tell me this question, if the ratio of maximum to minimum intensity to the superimposing waves is 64, right? Then ratio of amplitude is given by, right? So if you are asking, let's say, ratio of maximum intensity to minimum intensity, right? So what will be, let's say, maximum intensity, what can you write it as? Maximum intensity is proportional to A1 plus A2 whole square, and minimum intensity is proportional to A1 minus A2 whole square. So take the ratio, and this ratio is given as 64, right? And the ratio of amplitude they are asking. So A1 plus A2 whole square divided by A1 minus A2 whole square is equal to 64. Take square root both sides, and you can directly find relation between A1 and A2, or A1 by A2 ratio you can find out. But the same formula you have to use, okay? All right, so coming here, fringe width, right? So fringe width is lambda d by small d. And if you see in our question, we are not changing capital D or small d, right? Capital D is the distance between the slits and the screen, right? This is capital D. So this one is your screen. We had discussed this previously. And here slits are placed over here. Capital D we are not changing, and small d is the distance between the two slits, right? That is also not changing. So beta, right? This is your beta. So beta is proportional to lambda. All right, so fringe width is proportional to lambda. So that is what we are going to use over here, right? So fringe width is proportional to lambda. Okay, this width of fringe, we are calling it as beta. Here initially beta is 4 mm, right? So we just have to use beta 1 by beta 2 is equal to lambda 1 by lambda 2. Okay, you just have to substitute the values. So beta 1 initially is 4 mm, right? So 4 mm by beta 2 is equal to, initially lambda is how much? Lambda is 450, and finally lambda is 700. So 450 by 700, okay? Nanometer by nanometer get cancelled. So beta 2 from this you can find out. So beta 2 comes out as, just cross multiply. So 4 into 700 upon 450, right? You can cancel the terms, 0 and 0, right? Cancel by 5 also, this becomes how much? 14, this is 9, right? So it comes out 56 by 9, right? So roughly it will be more than 6, little bit, right? 54 by 9 is your 6, so it will be little more than 6. So the correct answer will be 6.2 mm. You can divide and find out if you want. All right. So this was one question for fringe width. It was a revision, right? All right. So moving on to waves, right? And waves, let us do some problem on open organ pipe and closed organ pipe, right? If you remember the formula for both of these pipes, right? The harmonic, for nth harmonic, what will be the frequency, etc. So if you remember, for open organ pipe, so let's say its length is small l, and here for closed organ pipe, let's say the length is small l, right? So what was the frequencies you were getting? What were the values, right? For open organ pipe, it was, right, V by 2L, then 2V by 2L, 3V by 2L, right? If you remember this order, lots of questions you would be able to do quickly, right? There is no need to keep deriving the same formula again and again, right? And for closed organ pipe, the first frequency is V by 4L, then 3V by 4L, then 5V by 4L. And how are the orders going forward? If you see, the denominator remains the same, but the numerator, right, 1, 3, 5. So what will be the next one? 7, isn't it? So the next one would be 7V by 4L. We will do some good questions on this one also. Right? And here, if you look at the numerator, 1, 2, 3, the next one should be 4V by 2L, right? And so on. Okay? And if, let's say, the length are not the same, the length are different. So for open organ pipe, I'm taking the length as LO. For closed organ pipe, I'm taking the length as LC. C for closed. Okay? And here, obviously, you have to replace it by LO everywhere. All right? And here, C. All right, so let's see what the question entails. If you see, read the question carefully. The fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe, right? So fundamental frequency as in the first frequency, right? First frequency, what was it? V by 2L, isn't it? For open organ pipe, V by 2L. The fundamental frequency of open organ pipe. So that was V by 2L. Third harmonic of closed organ pipe. If you come back to this expression, now what about harmonic and overtones, right? So if you want, I can write down, you can see, all right, so this is your first harmonic, all right? Likewise here also, first harmonic. This is second harmonic, third, fourth, fifth, so on. Okay, so if you want, we can write down this one. So this one is your fourth harmonic, right? But this won't be the fourth overtone. Okay, so please remember, this would be the first overtone, second overtone, third overtone, right? So if this is fourth harmonic, this we can also call it as third overtone. Okay, lot of students get confused. That is why I have written the order as well. Okay, open organ pipe. So let's say for closed organ pipe, this one is your first harmonic, but not the first overtone. First overtone will be the next one. So this would be your first overtone. Okay. Second overtone, third overtone, so on. But this would be which harmonic? For harmonic, you just have to focus, see what multiple it is of the fundamental frequency, right? If you see, this is third multiple of fundamental frequency, so we can say it is third harmonic. Fifth multiple, so fifth harmonic, like that. Similarly here also, okay, fourth multiple of V by 2L, so fourth harmonic. And this one would be third harmonic. All right, so I hope you have understood. Let's see, we'll do some question. Do this question, for example, right? Fundamental frequency of open organ pipe, that is V by 2L. And remember, the length is not the same, right? Here if you see in the question, they have said if the length of closed organ pipe is 20, the length of open organ pipe they are asking. So that means the length is not the same. So okay, so length LL, you won't take L everywhere. If you take L this one, you have to take different L. So let me call this as LO for open organ pipe. This fundamental is equal to third harmonic of closed organ pipe. What was the third harmonic? Third, right? Third multiple of fundamental frequency. You can remember it like that. Third multiple of fundamental frequency. What was the fundamental frequency for closed organ pipe? V by 4L, right? So V by 4L. This is different L, so LC. So I hope it is clear. Okay, and what is V over here? V is the speed of sound. Okay, because sound is the wave which we are considering in that pipe. So just have to cancel the terms. You see over here, simple cutting. V and V will get cancelled, right? V cancel, 2 and 4 cancel, become 2. So what is the length of open pipe? LO, take it over there. So LO becomes 2LC, bring it over here, 3 also. So 2LC by 3. Okay, 2LC by 3. So just substitute the values. LC is given as 20. So 40 by 3. Okay, 40 by 3. So 39 by 3 is 13. So little more than 13. So this comes out to be 13.33, like that, which is our first option. All right, 13.33. So please note it down. I hope this was clear. Let's do one more. Okay, little more. Let's do another. See over here, fundamental frequency in open organ pipe. Next question is equal to something. So what is the fundamental frequency of open organ pipe? Write it quickly and immediately. What was that? V by 2L or 2L naught or 2L0, whatever, equal to third overtone of closed organ pipe. So is that equal to third multiple of fundamental frequency? No. Third overtone means the number that I have written in that order. Please see that order again, right? V by 4L, then 3V by 4L, right? So this was first overtone, second overtone, then third overtone. The third overtone will be 7V by 4LC. That's it. See, that's it. The question might look complicated. See, we reduced it to a very simple expression. You just have to cancel the terms now. If you cancel the terms, we cancel, and here we have to find out length of open organ pipe. So LO, take it over there. So LO becomes 4LC over here, right? So 2 and 4 also cancel, 2. So 2LC by 7. Okay. And closed organ pipe length is 35. So 35 by 7, right? Simple mathematics. 35 by 7, 5. 5 into 2, 10. So 10 is your answer. Okay? 10 is your answer. So I hope this one is clear. Yeah, so it's me, someone is asking. In closed organ pipe, 2n plus 1 V by 4L. Then for fundamental, we have to take n 1 or 0. So remember, in fundamental frequency is V by 4L only. So depending on the formula you write. So let's say, for example, you are saying the formula is 2n plus 1 V by 4L. So in that one, you have to take n as 0. Only then you will get V by 4L. So please remember that order. Okay, please remember that order. Instead, if you had written 2n minus 1 V by 4L, in that case, you will take n as 1. So that 2n minus 1 becomes 1. So 1 V by 4L becomes your fundamental frequency. So focus on the fundamental frequency, and then you can equate it to this one. You can find the value of n. All right. Yeah, so I hope this one is also clear. Moving on to our next question, which is also very simple and very similar also, right? Again, here if you see what is given, this is literally the reverse of the first question that we did, right? Fundamental frequency of open organ pipe, which we did just now. But here, fundamental frequency of closed organ pipe. What is the closed organ pipe fundamental frequency? The first term, that is V by 4L, right? So V by 4L, but LC I will write for closed, is equal to third harmonic. Harmonic meaning multiple. So third multiple of fundamental frequency of which pipe? Of open organ pipe. Okay. So fundamental frequency open organ pipe was V by 2L. So V by 2L, but L not over here, or L0. So that's it. So just solve it now. You'll get the answer, right? Simple. You see, V cancel. This becomes 2. And length of open organ pipe is given. So LO is given over here. LC we have to find out, right? So LC take over there. So LC will become L naught over here, right? So L naught by 2 into 3. So L naught by 6. L naught is given as 48. 48 by 6. Okay. Correct answer is 8 centimeter. All right. So simple expression. All right. So very well. Moving on to our next topic, oscillations. Right? Oscillations, we had done very good questions few sessions ago. So this question is much more simpler than that one that we did, right? If you see, a particle is executing SHM of amplitude A, right? The distance of the point from equilibrium position, right, at which potential energy is 25% of kinetic energy. So let's say this is the, we can equate it, or we can consider an equivalent of that particle which is doing SHM. An equivalent system is block and spring system, right? So initially, let's say it is at equilibrium position, okay? So initially it is at equilibrium, all right? So this Initially it is at equilibrium, right? Then what do we do? How do we make it undergo SHM? We stretch it and leave it, or we compress it and leave it. So it will keep oscillating like this, similar to that particle. So let's say now it is oscillating. Okay, it is oscillating. And what is the amplitude of this one? A, capital A, similar to the particle, right? The particle was undergoing SHM of amplitude A. So if you see, this block will come somewhere over here, right? And here the amplitude is A. So x is equal to A over here. And at some intermediate point, okay? Let's say at this x, some intermediate point, this x we have to find out. Here when this block was in this position, right? And if you see, what about this extreme position, right? Extreme position, what do we know about this extreme position regarding kinetic energy and potential energy? We know that kinetic energy will be 0 because the block has to come back, isn't it? It's not gonna keep elongating from here, right? So here kinetic energy will be 0. And what will be potential energy? Half k x square, that is the formula. So here it will be half k a square, right? So here it will be half k a square. Okay, and here at this intermediate position, what will be the potential energy? Half k, here we will write x square because this x we don't know. Okay, and another thing is also given, from equilibrium at which potential energy is 25% of kinetic energy. So potential energy U is 25% of kinetic energy. That means 25 by 100 of kinetic energy. That means 1/4 of kinetic energy, right? So kinetic energy would become how many times of potential energy? 4 times, right? So if you want, here we can write down what will be the kinetic energy. It will be 4 times of this much. 4 times, right? So 4 times of half k x square, right? Now what are we going to do? We are just going to equate, right? Because remember, the energy of this system has to remain the same. There are no dissipative forces, okay? Here if you see, this block is undergoing SHM on a smooth floor, all right? So there is no friction, nothing. Total mechanical energy will remain the same. Okay, so what is the total energy over here? Half k is a square plus 0. So half k a square, right? And what is the total energy over here? If you just add them, it becomes 5 times 1/2 kx square. So I can write down total energy in the intermediate position. So 5 times half kx square, right? 5 times half kx square is equal to half k a square. So half k a square. All right. So whenever a similar SHM question comes up, please remember the spring block system. Okay, that solves your question a lot. You just have to solve them now, right? Simple k by 2 cancel. 5 goes over there. So x square is equal to a square by 5, and x will come out to be how much? X will come out to be a by root 5. Okay. X will come out to be a by root 5. Yeah, so someone is saying, okay, that's a different question. Yeah, that's a previous question, yeah, 10 centimeter. All right, so anyway, let me give you another question similar to this as homework for you guys, right? Same thing you have to do, but here if you see in the next question, here it was 25% of kinetic energy, right? But now if you see, you can take this as homework. Find the position at which potential energy is equal to its kinetic energy. So it is equal now. So solve it carefully, you will get the answer as a by root 2, okay? So this you guys can take as your homework, a by root 2. So please try this one. We will try to do a different question, right? If you see a different question, SHM of amplitude A, just like that spring block system, the distance of the point from equilibrium position at which speed is equal to half of maximum speed. So you also need to remember, apart from the expressions for energy, kinetic energy and potential energy, you have to remember the expression for speed also, right? What is the expression for maximum speed of that particle, or let's say maximum speed of this block which was doing SHM? That is omega into A. Okay. And what is the general expression for V? Particle speed, right? So particle speed, this is also particle speed, but maximum particle speed. This is I am writing for general. So V can be written as omega times under root A square minus X square, right? This, remember, you can derive it using the original formula for X, right? X can be written as A sin omega t. From that you differentiate once, you get V. So from that you can write these expressions. Okay. So here if you see what is given, particle speed is equal to half of maximum particle speed. So this was your particle speed, but now they are saying, right? Now they are saying this would be equal to, just a minute, this would be equal to half of maximum particle speed. So half of, like this, omega A by 2. So now you have to just solve them, right? If you solve carefully, you will find out, yeah, if you solve, omega and omega will get cancelled. Now you have to, you can square the terms, right? So under root A square minus X square is equal to A by 2. Square them. So A square minus X square is equal to A square by 4. Take this minus X square to that hand side. So it becomes A square, and bring that A square by 4 to left hand side. So A square minus A square by 4 is equal to X square. Okay? Simple LCM. So this is 3A square by 4 equal to X square. So X will become how much? Root 3A by 2. Okay, root 3A by 2. If you remember this expression for particle speed, we can simply do this question. All right? Yeah. Yeah, so I hope you guys are finding it interesting until now, right? And if you have, let's say, if you want to revisit some topic, you can pause and rewind back and listen to that same question. If you want, you can derive this expression also. All right? All right, so anyway, moving on to 12th class topic now, semiconductors, right? And here we had talked about ideal diodes, right? We had talked about PN junction diode in forward bias and reverse bias. And what about in the ideal scenario, right? If you see the first question, in the figure shown, the voltage drop in forward bias diode is 0.2 volt. Remember, but if you remember, I had drawn a big table and we had written for forward bias diode, if it is ideal, it will behave simply as a plain wire. We can replace it by plain wire. Why? Because it will offer no resistance, nothing. And it will offer no potential drop also. But here it is offering potential drop. So it is not an ideal diode. So please remember, it is not an ideal diode, right? Now, what are they asking here? Find the voltage difference between P and Q. You have to find the voltage difference. So current is flowing over here from P to Q. And if you see, there are two resistors connected as well. They are in series or parallel? They are in series. So we can find what is the total resistance in this series combination, R1 plus R2, right? If you want, I can draw the same diagram over here. Okay, so P you have, right? And I'm drawing a single resistance. 10 plus 5 is 15, right? So 15 kilo ohm, okay? And then you have the diode. And this is, let's say, Q. Like this, right? Current is flowing, I current is flowing, and current flows from high potential to low potential. And here we have a voltage drop also. How much? 0.2. So remember that, because now we are going to write KVL, which you studied in your third chapter, current electricity, right? So please see carefully how I am writing KVL from P to Q. Okay, so VP, right? Current flowing from higher to lower, higher potential to lower potential. So it will become how much? I into R or minus I into R? Plus IR or minus IR? It will be minus IR. Okay, so minus IR. Why? Going from higher to lower. And then again you have a voltage drop over here, 0.2. I'll simply write it as 0.2. And now you have reached point Q. Right? This is how we write KVL between points P to Q. But here we are supposed to find potential or voltage difference or potential difference between P and Q. So they are not asking this expression, right? So they are asking Vp minus Vq, they are asking. Vp minus Vq. So bring this Vq to left hand side and take these to right hand side. So this becomes plus IR, I into R. I is how much? 0.4 milliampere, right? So 0.4 milli meaning 1 by 1000 ampere, right? 0.4 by 1000 ampere into R resistance. Total resistance was how much? 15 kilo ohm. Kilo meaning 1000. So this is 15,000. So 15,000 ohm plus 0.2. Okay. Yeah, so I hope this one was clear, right? So 1000 and 1000 cancel. 15 into 4, 60. You place the decimal as well. So 6 plus 0.2. It becomes 6 plus 0.2, right? I hope this was clear. 6 plus 0.2, and the correct answer to this one will become 6.2. All right. Correct answer would become 6.2. And also remember, what if this diode was reversed, right? If I had placed it in a reverse manner, right? And let's say it is an ideal diode. In that case, what would you do? Right? In that case, what would you do? Or let's say in this question itself, if I had said it is an ideal diode, then if it is an ideal diode here, forward bias, then this 0.2 term will not come, right? So only I into R would be the answer. That is 6 volt would be the answer. In that case, 6 volt would be the answer. But if it were reversed and it becomes an ideal reverse biased diode, in that case it will offer highly, we say, infinite resistance or very large resistance, right? Very large resistance meaning current won't be flowing over there. And that means the potential drop, nothing. So potential difference, we can say, remain the same, then because no current is flowing. Okay. Or otherwise, let's say if some big circuit is given, in that case some other diodes are also drawn over there, and if here this were reverse biased, then current won't flow through this part of the circuit. But if there were other wires, then there may be the possibility that current will flow through that wire. It won't flow through this wire because it is reverse biased. But here there is no problem, right? Here it is forward biased. Yeah, so simple KVL application concept. So I hope this one was clear. We move on to ray optics, right? Ray optics, we had talked about total internal reflection, then we talked about compound microscope, right? If you remember, we talked about Snell's law, we also talked about prism, isn't it? But here let's see what the question is. If you see, the question says a ray of light traveling inside a rectangular glass block of refractive index √2, right, is incident on glass air surface at some angle of incidence 45 degree. Okay, at angle of incidence 45 degree. So it is traveling inside a rectangular glass block. So let me draw a rectangular glass block, and refractive index is given. So this would be your mu. Okay, it is incident on glass air surface. So let me first draw for you guys. We'll come back to that question. Okay. If you want, I can close it. I could have drawn a much smaller surface also. Anyway, and this is your glass. This is air. Right. Here mu is how much? √2. And for air, we say refractive index is approximately 1. Right. For vacuum, it will be 1. But for air, approximately 1. So I'll just write mu is equal to 1. Remember, it is not exactly equal to, it is approximately. Just a minute. Yeah, so voice okay. I hope you're able to hear me, right? All right, so very well. Continuing with the question. So what are they saying? A ray of light traveling inside the glass is incident on glass air surface at angle of incidence 45 degree, right? So let's say it is incident like this. Here, this is the surface we have, isn't it? So what I will do, I will draw a normal, okay? This is your normal, and this is the angle of incidence, I, right? And this I has been given as how much? 45 degree. And then they are asking what will happen to this ray, right? Will it, let's say, come out just like that, or will it bend, or what goes on, right? So what we are going to do, let's say it bends. And how is it going to bend? Is it going to bend away from the normal or towards the normal? See, from higher refractive index to lower refractive index, right? Which means from denser medium to rarer medium it is coming. So it is going to bend away from the normal, isn't it? So let's say it bends like this. And here it is I, and let's say here the angle of reflection or angle of refraction is R, okay? So now what are we going to write? Snell's law. Snell's law is mu sin I or mu sin theta is equal to constant. So here what will we write? Mu into sin I, okay, is equal to mu into sine of angle over here in air. What is the mu over air? For air, or let me just write mu for now, mu into sine R, okay. So nothing big calculations so far. And this one is your glass, and this is your air, okay. So mu of glass is how much? Root 2. Sine I, sine 45 degree is how much? Sine 45 degree is 1 by root 2. Mu of air is how much? 1. And this is sine R, because R we don't know. We don't know the angle so far, isn't it? So root 2 will get cancelled, and sine R comes up to be 1, and that is R will be equal to 90 degree, right? Sine 90 is 1 and sine 0 is 0. So sine 90 is 1. So what does that mean exactly? See, how did this ray bend? See, it is going to bend away from normal, but how exactly it is coming out? This angle R is going to be 90 degree. So if you want, we can redraw it, okay. So how will the ray look like? It will look like this. Okay, I have drawn multiple arrows so that you can see, and this would be 90 degree, right? And this I has a special name also. If you remember, this I is called critical angle, right? Because when the ray of light is going from denser to rarer, and it is incident at critical angle, so the ray grazes out, okay, and it is touching the surface and it is coming out, okay. So this I is critical angle, okay. So if you want, you can write down critical angle is equal to 45 degree, right? Critical angle is equal to 45 degree, okay. And how is the ray coming out? It will graze out, right? This one is wrong, isn't it? It will emerge out without any deviation. That is not true. It deviated. It will not emerge out. That is not true. This is also not true, and this will be true in which case? In TIR, total internal reflection. And in TIR, the angle of incidence has to be more than critical angle. So that means if it were incident, and let's say an angle greater than 45, let's say 46, 47, 48 degree, in that case, you would have ticked this answer. It won't emerge out, okay. And this also wrong. It will emerge out at an angle 30 degree, right? Instead, it emerged out at what angle? 90 degree. Okay, so option 2 was the correct answer. All right, so moving on. Yeah, so moving on. Just a minute. All right, so we are entering another topic now, mirrors, right? For mirrors, convex mirror and concave mirror, right? So the diagrams have been drawn over here, and if you see, you already studied this in your 10th class also, isn't it? So for convex mirror, let's say the rays are falling like this, okay? The rays are falling like this, all right? And the focal length of this convex mirror, will it be positive or negative? It will be positive. Why? Because remember, the rays are coming from the left, and the focus, right, where? towards the right, isn't it? Behind the mirror, you can call it like that. So for convex mirror, we can say F is equal to positive, right? Which is the reverse for concave mirror, right? Here the rays are, let's say, falling on the mirror like this, and the focus is on the left hand side. Okay, so this is the focal length, and here if you see, this is the focal length. This total is the radius of curvature R, which in our case we took it as R is equal to 2f, twice of f. All right. And in concave mirror, we will say f is equal to negative. So please remember, just from the f itself, you can comment what kind of mirror it is. All right. And all other cases, for example, the mirror formula, which is 1 by v plus 1 by u is equal to 1 by f, that will be valid for both mirrors. Okay. So let's see the question. What it says a concave mirror, right, has focal length. So concave mirror has, what did I say? The focal length is negative, isn't it? So we will say for this one, f is minus 20 centimeter. A real object placed at a distance 40 centimeter in front. Okay, object is placed in front, meaning towards the left, right? So this is your object distance. All right. So object distance u is equal to minus 40 centimeter. So please remember why we wrote minus sign in both cases. Okay, it is towards the left hand side. Okay, and remember it is on the same side from where incident ray is falling. The mirror produces an image from pole at a distance of. So what is the pole? This one is the pole. P is the pole. All right. So you just have to use simple mirror formula. So 1 by v plus 1 by u is equal to 1 by f. I told just now, right? So just put the values. So 1 by v we don't know, right? U is minus 40. This minus 40 will go that hand side, and that will become plus 1 by 40, right? 1 by f, f is already in minus sign, so minus 20, isn't it? You just have to take LCM now, solve it. Minus 2 by 40, and this becomes minus 1 by 40. So that means the final V comes out to be minus 40 centimeter. Okay, so the image will be formed on which side? Towards the left hand side. Okay, this is the concave mirror. On the left hand side, image is being formed. And the answer will be 40 centimeter. All right. See this question, it's also very similar, right? Very little, looks very basic, but very similar. Convex mirror now. Convex mirror meaning focal length is plus, right? So f will be plus 20 centimeter. Object is placed at same distance, 40, right? So u is equal to minus 40, and v we have to find out. Use the same mirror formula again. Let me write the mirror formula once more for you guys. Substitute the values. 1 by v becomes 1 by 20, right? Take it to that hand side. So 1 by v is equal to 1 by 20 plus 1 by 40, right? So this you can write it as 2 by 40, right? So 2 by 40 plus 1 by 40, that is 3 by 40. Okay, so v comes out to be how much? Plus 40 by 3. Okay, plus 40 by 3. Plus meaning to the right hand side. Convex mirror, right? You see, convex mirror, left hand side negative, right hand side is positive. Okay, so the image would be formed at plus 40 by 3 centimeter, and that would be your answer. Mirror produces an image from pole at a distance of. Okay, very well. Let's go to another topic, right? Compound microscope. This also we have discussed in our previous sessions, if you remember. And this was the big diagram that I had talked about, isn't it? You have the objective lens and then the eyepiece lens, right? And here, if you see in this diagram, where is the final image being formed at? D somewhere, right? And it is a inverted and magnified image. Okay. And we had also talked about magnification of this objective lens. That is simple, V by U. Okay, so that is V naught by U naught, right? And what about for eyepiece lens? It will be D by FE or 1 by D by FE. Remember, the focal length of this lens is F naught. Okay, so f naught, Fe meaning focal length of eyepiece lens. Okay, so here magnification would be 1 plus d by Fe. Why 1 plus? If it had been normal adjustment, that means the final image is being formed at infinity, somewhere at infinity, right? In that case, we would have written Me is equal to d by Fe, simple d by Fe, but here 1 plus d by Fe. All right, so come here. What are they talking about in the question? They are saying compound microscope has magnifying power 30. We have written M naught and Me, right? So what is this magnifying power? 30. So 30 is nothing but M naught multiplied by Me. That's it. Okay, and focal length of eyepiece is given. So Fe is given. Least distance of distinct vision, capital D is given. And they've already said the image, final image is being formed at D. So you can find the formula for magnifying power of eyepiece lens, isn't it? So Me you can find out, isn't it? Me is this formula, 1 plus d by Fe, right? So Me will come out to be how much? 1 plus d is 25, Fe is 5, right? So Me comes out to be 6, right? You just have to substitute 6 over here. M naught will come out to be how much? M naught will be 30 by 6, right? That's what they're asking, isn't it? Calculate the magnification produced by objective. So 30 by 6. So the answer should be 5. But please remember, magnification is height of image by height of object, right? So if the image is inverted, magnification has to be negative. Okay, but here if you see in the diagram also, the original object was erect, the final image is inverted, right? So if you see over here, that is why even while writing itself, if you want, you can write down. Here I have only written the magnitude of magnification. If you want, you can write minus 30 over here to total magnification, and magnification of objective will also be negative. Okay, because it is forming a inverted image, isn't it? That's why. Yeah, so I hope this was clear. I am giving a very similar question to you as homework. Same formula, same diagram, same formulas. Okay. Yeah, so this question you can take as homework, all right? And the answer, I think, should come out to be 25 by 9, all right? So we are going towards the last topic of the day, magnetism and matter. And this, if you see, is a very simple question. The first one, magnetic field lines due to a bar magnet, right? So which one it should be? Remember, magnetic field lines for a bar magnet come out from the north pole and they go towards the south pole, right? So outside the magnet it should be from north to south, but inside it should be like this. So very simple one, this one was, right? From north to south it is going, and inside would be from south to north. This obviously is wrong. Okay? The next questions are very simple oral questions, all right? If you remember, we had talked about a few topics, right? Diamagnetic, paramagnetic and ferro. For diamagnetic, remember the susceptibility, its variation with temperature, right? Susceptibility remains constant. Okay, I'm talking about magnetic susceptibility. Right? Magnetic susceptibility, it implies how much that magnetic material can be magnetized. Okay, so the first one is diamagnetic substance. If you see, yeah, the variation of magnetic susceptibility with absolute temperature for diamagnetic substance, which remains the constant. Xi remains same with temperature. So which one would be the correct answer? This one, right? Because Xi is going to be negative, isn't it? Xi is going to be negative and it remains the same. Right? The another question can be asked for paramagnetic substance. So please remember, as per Curie's law, Xi varies inversely with temperature. So it won't remain the same. It is going to decrease with temperature. So which would be the correct answer? This one. Okay? Rectangular hyperbola, it will decrease with temperature. All right. And we come to our last, ferromagnetic, right? And for ferromagnetic, please remember, let's say this is Curie's temperature. Okay, so after Curie's temperature, it will start behaving as paramagnetic. So if you see, after Curie's temperature, it will start dropping. And for ferromagnetic, we already know Xi is very high. Okay, so before Tc it has some value, it has some nature, but after Tc it will start dropping like paramagnetic. Okay, so the correct answer for this one is also this one. Okay, this one is for your paramagnetic, this one was for diamagnetic. All right, everyone. So I guess we are done for today, and I hope you guys had a great time. So keep watching and keep practicing. Thank you for watching.